In this video, we're going to continue our journey into containers with network services and volumes. So let's try something a little bit different. We're going to make use of the Nginx web server, as this is a very convenient image for testing both networking services and volumes from a container viewpoint. So we'll head to our terminal and we'll do a docker run --rm to clean up. We'll specify Nginx, and we don't actually need -it as we're not going to be interacting with the terminal. Lastly, Nginx is our image. We can see that it's pulled the image as part of the run command, as this image wasn't already available on my system. Again, we can actually see the individual layers there. We can see the digest, and it's currently running in the foreground, which can be convenient in some cases, but for us, ideally, we'd like this to be running in the background. So we'll just Control-C this for now. And we'll update that command so that it actually includes -d to detach, so that this runs in the background. Now, as the output, we get a container ID, and we can run a docker ps to see this in full. Note there, it has a random name, and this is listening on port 80. Remember that format of how that actually looks right now, 80/TCP. At this time, it's not actually easy for us to access Nginx in this container. Although the container is listening on port 80, this is not published and therefore is not easily accessible to our local machine. So let's fix this. We're going to stop that container and I'll show you a nice little trick here. We only need to give it enough to identify the container ID, and because we used --rm, it's going to automatically clean that up. And if we check again, we can see that that's gone. Okay, so let's bring up that last command, and this time we're going to add -P to publish all ports. By the way, just so you know, the -P publish parameter makes use of the expose instructions in the container image. So you can actually see this on the Nginx image if you look at the instructions on Docker Hub. So now, if we take a look after running this with -P, we can see that this is now bound on 0.0.0.0, which means it will be available on all IPv4 addresses on this particular port, which is then going to port 80 in the container. So now if we access this in a browser, you can use a browser, or if you have curl installed, you can just use curl. We can see the welcome page for Nginx, and I'm just going to do this in a browser so you can actually see this as well. Each time we run an instance this way, it will use a random port. So let's run another instance, but instead what we're going to do is we're going to use a different format and specify the actual port that we wish to use. So bring up that command and we'll use a lowercase -p to specify our port, and I'm going to use 12345 as the source port, then :80 as the container destination. Okay, and we now have our new container instance alongside the other one, and we can access this accordingly again. So if I actually do this with curl, and we'll just change that port so you can actually see that, and again, I'll just do this in the browser. Okay, perfect. Let's get rid of the old one that's not actually listening on port 12345. So if we stop the container, the --rm will automatically clean that up for us. The web page in this instance that we have running on 12345 at the moment is pretty generic. It is the standard Nginx template that comes with the Nginx image. So let's take a quick look inside this container. So with this container running, we can actually execute another process inside the running container. Although this container is running Nginx as its main process, so that would be process 1, let's run another process within the container. So we'll execute a shell and we'll take a look inside. To do this, we're going to use docker exec. As it actually says there, run a command in a running container. So what we're going to do is a docker exec -it, so we want this to be interactive with the terminal. We'll put the container ID of the Nginx container that we've actually got running, and a command of bash. Okay, so now we're inside the container. Let's find the default location for the index.html file, which actually serves this web page. And for this, I'm going to just use a Unix find command. So find all files from / with a name of index.html and redirect any errors to /dev/null. Okay, so there's the path of our default web page, and if we update that file and reload, so what I'm going to do is just do an echo hello and overwrite the file. And if we reload that in our browser, this will have updated. Now, going into a container and modifying files isn't efficient or a good strategy at all. A better approach is to use a volume that contains our website and to pass the volume to the container. So let's exit out of that and we'll just clean up the current container. Okay, so what we're going to do is we're going to create a directory and we'll create a simple file. So echo hello from James and redirect the output to index.html in that directory. And we'll modify our docker run command so that we provide a volume mount. This needs to be a full system path, by the way, so -v, full path on our system, then : and the path we want to actually override within the container. Okay, so now we've actually passed in a volume to that container. And if we actually go back and we check in our browser, you can actually see there we've got hello from James. And the great thing with this approach, I could actually update that file locally. So what I'm going to do, I'm just going to append my surname to that local file. So I'll just echo spurring onto the index.html. And now if I reload, we're good to go, showing the power of volumes. Finally, before we go, we'll just clean this up. Okay, so hopefully now you've got a good understanding of networking services and volumes within Docker. In the next video, we're going to take our Docker knowledge to the next level by building our own container images. Thanks for your time, and I'll see you in the next video.